Quinn. I'm a co-founder of Qinov8 and I'd like to present the Aquapea. Leaks can be found using some wonderful technologies, innovations and even techniques. But how do we fix them? We still use a method that's been with us for hundreds of years, digging up the pipe. Well, the Aquapea has now changed that. It stands alone, totally unique in being able to offer an actual physical solution to repairing leaks without having to excavate. The Aquapea is made from two components, a specially formulated 2-part polymer and a buoyant polypropylene core. The polymer is hand mixed for 30 seconds, then wrapped around the core to create the Aquapea, and it can be used on all pipe materials. So, if the leak is losing 4 litres per minute or more, then the Aquapea can be used. The customer's internal stop tap is closed to isolate the leak. Then, after closing the external stop tap at the meter chamber, the meter and non-return valve are removed. The prepared Aquapea is dropped into the meter chamber and the non-return valve and meter are put back. The water is turned on and the Aquapea free swims through the pipe, drawn by the flow of escaping water until it reaches the leak, where the Aquapea now completes its curing process, bonding to the pipe. The pressure is left on inside the pipe for 15 minutes, then the internal stop tap is opened back up. The customer's supply is now back in commission and ready to be used. I'd like to show a comparison of traditional repairs versus Aquapea repairs. Of course, each water company will differentiate slightly, but this is a general view. So traditional repairs, we have stop tap checking, high meter reading, visible leak reported, pool pressure reported. This is how the leak is first discovered. So the leakage technician then investigates. Following investigation, the leak is confirmed, reported, put into the system. The customer is then contacted to arrange for a leak repair team to attend site. This takes on average around 3 weeks to happen, called the median repair times. If the leak is located, it's then excavated and repaired. If not, then partial or full replacement by open cut and molding is done to replace the section of leaking pipe, and costs can range from £700 to £1,500 and higher, depending on difficulties, and can take anything from 2 hours to 2 days to complete. Backfill and reinstatement of excavations to follow, then the job's complete. The total time involved, 3 to 4 weeks. The Aquapea repair, again we have stop tap checking, high meter reading, visible leak reported, pool pressure reported to flag up the leakage. The leakage technician investigates, the leakage technician confirms there is a leak, but can now engage with the customer to use the Aquapea. So the Aquapea can be used immediately. And if the Aquapea fully repairs the leak, job complete in under 1 hour. If your Aquapea results in a leakage reduction, then significant water savings are being made for the 3 weeks it takes for the repair team to be allocated the job. So based on the average Aquapea reduction for one job, this equates to more than 210,000 litres of water saved over that 3-week period. For example, one technician using Aquapeas could easily save 40 litres of water a minute in 1 day by performing several leak reductions and repairs. That would be a huge 1.2 megalitres a day of water savings over those 3 weeks of median repair time. To summarise, the Aquapea is a much quicker solution, taking up to 1 hour compared to a traditional repair of 3 to 4 weeks. The Aquapea, at much less than £100, is a fraction of the cost compared to traditional repairs, which range from £700 to £1,500, and possibly more, as we said, depending on the severity and location of the leak. And importantly, the disruption to the customer and the environment is almost non-existent, with 0 excavations, a big reduction in the carbon footprint, there's no mess, and only 1 visit. Reducing leakage. The AMP7 leakage targets set by Ofwat are an incredibly challenging 15% from 2020 to 2025, and water companies have also pledged to be carbon neutral by 2030, another huge target. Previously, 9 out of 20 water companies missed their leakage targets, resulting in heavy fines, so you can see how difficult this will be to achieve these goals this time round. The Aquapea will reduce customer supply pipe leakage by, on average, 70%, and will not only reduce the carbon footprint by 99% because of 0 excavations, but will also save on the energy used to replace the lost water from the treatment plant back to the customer's tap. What opportunities do we have? Well, the challenges I've just talked about are immense, and it will take numerous innovations and best practices to be successful, but regularly using the Aquapea on a daily basis will help give water companies the opportunity to achieve these leakage and carbon reduction targets. 1 in 3 people have experienced a leak in this country. That's 22 million people, and that's a lot of leaks. and the cost of water is quite expensive when it's running away into the ground and never to be retrieved. 1 cubic metre of water lost through leakage every hour can cost the customer £70 per day. That's over £25,000 per year. So we must act now and reduce leakage anywhere and everywhere to keep costs down and prevent imminent water shortages in the UK and across the world. Case studies. Welsh Water recently completed an innovation case study on the Aquapea. They had 22 historical jobs which they couldn't offer to the customers as part of their normal leakage offering of one free repair or a section of pipework to be replaced. This was because of engineering difficulties. So they used the Aquapeas on these leaks. They were successful in 18 of the 22 jobs. 7 were fully repaired and 11 had significant reductions, resulting in savings of almost 7.5 cubic metres of water per hour. That's 0.18 megalitres a day. Using the Aquapea enabled Welsh Water to support their private leakage offering, increasing the number of customers they could support that would have not been offered anything traditionally. Just over a week ago, 2 leakage technicians for United Utilities visited a local charity-run community centre in Bollington, Macclesfield, who had a significant leak. It looked like the customer's supply pipe would have to be replaced, digging up the drive to prevent any more leakage. The 2 technicians, Greg and Martin, explained about the Aquapea to Mrs. Haddleton and agreed to use it on the leak. The Aquapea was successful in fully repairing the leak, leaving Mrs. Haddleton and the charity very happy. To such an extent, Mrs. Haddleton contacted United Utilities to nominate both leakage technicians for outstanding customer service, for keeping her informed at all times, and for being polite and proactive in resolving the issue.
1 minute, Michael.
Fitting into existing practices, the Aquapea is a first response solution that can be utilised in nearly all leakage cases and requires little technical training. The leakage technicians can address immediately any leakage reported by carrying it in their toolbox, which dramatically reduces water loss by meeting repair times. On average, each Aquapea will save 10,000 litres of water a day. Customers are always happy to see water companies bringing in new technologies that make their leakage experience on their property as painless and cost-effective as possible. So who benefits from using the Aquapea? Well, the first column, by driving down leakage and water, saving water, everyone benefits. Financially, the water industry and supply chain, plus the general public, benefit because water prices can be reduced. I think we all benefit from improving health and safety and taking care of the environment by reducing excavations. Operationally, everything runs smoother for the water industry and the employees because planning is made much easier. And with customer service improving, this leaves us all very happy. Thank you very much.
Thank you, Michael. That's really clear. Thank you. Super. So, Anna, you're the first one off the starting blocks. So would you like to ask your question?
Thanks, Michael, and for pivoting so quickly there to give us your presentation. My question is quite simple. Just where is Aquapea manufactured?
It's manufactured at our facility in Durham. Perfect. Handmade.
Thanks.
Is every single P handmade?
Yeah. They have to be individually put and weighed.
Oh, they do? Oh, right. Okay. Oh, right. So it wasn't being facetious then.
No.
Okay, Richard then, please.
Hi, thanks, Michael. Thanks for that. I'm interested, clearly, if we can fix the leaks straight off, then that's really good news for everybody. I'm interested in what looks like 60–70% of jobs that don't go according to plan. What happens to those? And what's been the experience? I presume there then needs to be a dig repair reactively.
Yeah, the 70% I mentioned was the water. That's the average reduction. So you have fixes, you have reductions, and overall it comes to 70%. The ones that obviously get the ones that get reduced do have to still be repaired. Yeah. So there is still implications. But it's the median repair times that we couldn't.
Yeah, you said 7 out of 22 were fully repaired. 18 out of 22 were partially repaired.
Sorry, Richard.
No, go on.
Right, okay, so all I was going to say was some leaks, all leaks are different. Some leaks are gaping holes, and the Aquapea won't fix those, which we accept, but it's the ones that they do fix and do reduce that are sort of beneficial.
Okay, thank you.
Luke, then, please.
Yeah, great presentation, Michael. And my question is around the risk and consequence of the Aquapea passing downstream. And I guess kind of how far can it travel? and you know, how long does it take before it cures? If you like it there, sorry.
Sorry, Luke, what was the last one?
So this is about how it cures. So how far can it travel down a pipe to find the leak?
The Aquapea travels.
Contact with the pipe.
Yeah, the Aquapea travels around about 2 feet a second, depending on the size of the leak. We have a method statement. All the guys who use the Aquapea, every guy that uses the Aquapea receives training from ourselves. We've trained over 150 guys at our facility in Durham. We now do, since COVID, we've been doing online training, which has been really successful. And what we do train them to do is ensure that the internal stop tap is closed prior to operation. And what this does is create one flow in that pipe and it goes to the leak. So there's no sort of risk of the Aquapea going to the customer's supply because it's got to travel to the leak. And that takes that risk away. So through the method statement and through the correct procedures, there's no risk.
That's great. Okay. Jeremy then, please.
Thank you, Michael, for that. Really interesting. And just asking about the different pipes, materials, and the splits and holes that you can fix. So obviously we've got a variety of materials. We've got cast iron or galvanized iron, we've got copper, we've got lead, and the old alkathenes. Which materials would this work on, and what kind of size of holes or splits would you recommend it for?
The best results is copper pipes. They've been the best results, tend to be more pinholes, and even the splits aren't long. We get a lot of success on black alkathene, to be honest, and they are generally splits, but they are very successful in reductions. Galvanized steel, there's not much of it about, so I can't really comment on that. We've had some fixes on them, but probably the worst type of fix for an Aquapea is a joint, because the water tends to escape from a joint different than it does to a split or a pinhole. So I would say that yeah, I would say the best result is for copper pipe. It does obviously bond to all materials, but yeah.
Lovely. Thank you, Michael.
Okay.
Fantastic. Any other questions, judges? Are we all happy? Great. So, Michael, that was great. Thank you very much. Luke wants to ask another one. There is time. So, yes.
Yeah, I was just going to ask about Regulation 31 approval, whether you've sought it or intend to seek Regulation 31 approval for use of the product on drinking water.
Sorry, Luke, I couldn't hear you.
Yeah, it was a question about Regulation 31 and whether you've sought approval of the product.
RAS approved.
Yeah.
It's RAS approved, yeah. We actually, RAS approved now, it's got NSF now for America. We've just found out today it's regulated in Australia. So, and now we're going for the French one as well. So yeah, it's approved.
I guess I might just ask a little question. We've got another minute to go, and obviously the Aquapeas, are they just? I know you showed us a range of sizes, but are they? Do you have to do the assessment first and then decide which peas you're going to use, or do you put more than one in at a time? How would you do?
Yeah, generally what the procedure is, you'll go up on site, you will shut the internal stop tap, you'll quantify the leak, you'll watch the meter, time it for 1 minute. That will tell you which size Aquapea to use. And then you follow the procedure where you'll turn off the external stop tap, you'll remove the meter and on return valve, prepare the Aquapea, drop it in, put everything back, turn it on, and then it goes to the leak. It's that simple.
Oh, great. So I take it when you're on site, you have a range of them in the van ready to use, so you don't have to sit off site again, I think. Yeah, okay.
Yeah, so you've got everything with you. Yeah.
Luke, you still got a hand up. Do you want to ask one last question and we'll finish?
Go on, Luke.
Yes, please. Yeah, I was just wondering what the opportunity is to expand this to larger diameter pipes.
We have done tests at our facility on larger diameter pipes, and what we found is you can only create a certain size Aquapea compared to the certain size main. So once you start upscaling, what we tend to find was the flow goes over the top of the Aquapea because it's in a bigger pipe. So it doesn't quite work the same as the smaller diameter pipes.
Brilliant, thank you.
Lovely. So, Michael, thank you so much.